So let's get started. Welcome to this session. I'm very glad that people found this. This is about the Milan network protocol, which is all about deterministic AV networks. My name is Henning Kaltheuner from audiotechnik, and this presentation will be held with 4 people in total. So we've got Morten Lave from Adamson, Tim Boot from Meyer and Genio Kronauer from L-Acoustics. And the mystery why these 4 competing companies work here together, well, you will find out in this presentation. So before we dive into any details, we have to talk about the philosophy behind this, because it's really a question, why are they doing this? And what is the motivation behind? Okay. Let's talk about network system trends first in general. We always hear this paradigm, everything will be networked at some time in the future. We already see today it's hard to find new audio products coming up on the market without a network connector. And it's getting more and more and more every year. And the reason is we see growing requirements for multifunctionality in systems, and also for the efficiency of products and systems. So more functions have to be handled with less people and less work hours in the systems. Whether it's mobile or whether it's fixed installed doesn't make a difference. But we should not forget, networking is just an enabling technology. It's not the value we are selling to our customers. We as loudspeaker manufacturers, we sell goosebumps. We sell excitement about sound. Networking is just make a signal go from A to B. It's pretty boring, to be honest. So we have decided that network should not be a competitive market. We should rather share a common ground on which we can make these things happen in a way that is of a benefit for ourselves and for our customers. And another trend I want to highlight, amongst others, I call it the fall of the one-size-fits-all paradigm. We have been told by marketing freaks in this industry for many years that there must be one network, and this one network is the one that makes us all happy, and it would do everything we would ever expect from it. And I'm sorry to say, but this is not only being challenged today, we think it's simply wrong. And I want to expand a little bit on this. However, what we're doing here is all about concentrating on true requirements for networking and to refocus on value we want to deliver to customers. So, the fall of the paradigm of one size fits all, what does it mean? I want to say we see 3 fundamental types of AV networks being around these days. The first one, I would say, is the all-purpose interconnectivity network, and the claim of this kind of network is connect everything with everything. And this means such a structure must be very common. It has a very low dedication to system or to workflow. The value even lies in the usualness and the commonness, and to be as unspecific as ever possible. And if you now start thinking about Italian poets, you are on the right track here, I think. The second type of network is the system network. And system means to provide a network structure for a system context. And this type of network, it has a strong relation to product and system value, to workflow and usability. Please remember, there were days, and they are still present, when you bought a console from manufacturer T, you also bought the T network. And when you bought a console from manufacturer V, you bought the V network. Why? Because the manufacturer needed to provide something which what he could sell as a system to the customers with a certain value, a certain usability, and a certain workflow. And he couldn't do this with something off the shelf. He had to do his own story. And this is about system networks. And the third type definitely is the wide area story. This is thinking network entirely from the requirement that signals and even workflows have to be bridged over large distances. And naturally, this is the broadcast home ground, where this is the main paradigm that determines everything. Now, Milan is primarily a system network, and it all came up because we as manufacturers found for the future, we need a network standard for our system solutions. We need to be able to create systems of a very high value for our customers. They must be future-proof, they must be nice to use, and so on. And we found that we exactly have the same problem, all of us. And that's really the thing. We need to own not only the standard itself, we need to own the implementation by ourselves, and we have to be independent from proprietary vendors, so we can run this as a solution for many, many years. And by the way, we also want to be creative. We don't just want to be locked into something and don't want to wait for Santa Claus bringing a new feature to us. No, we want to create the new features ourselves. So we need a platform for creativity and a platform for differentiation. There are many of these proprietary, incompatible system solutions in the market. Think of the console T with the T network and the console V with the V network, whatever. But it would be much better to use open standards for this, while still having a maximum interoperability in between. That would give us, on the one hand, the freedom and the future-proofness, and on the other hand, it wouldn't lock us on an island. So this is exactly what Milan gives us. Milan enables best system architectures. We can own the network, we can create the value proposition, we can plan for the future, and we can achieve interoperability. So you could also see it from the other side. You could say, what if top engineers and strategic thinkers from leading manufacturers in the world, what if they came together to design a network? Isn't that maybe the best case in being as close to customer demands as ever imaginable? So Milan is not only a system network, Milan is the manufacturer's network. It's a technical, but more so even a business decision for the top leaders in the market. So we have decided to work together. We have decided to make a huge investment in throwing together our knowledge, our expertise and strategic resources to produce something exceptional which will meet individual and collective requirements for our products and for our customer demands. Milan builds on open standard networking technology, and you will hear more about this from my colleagues in a few minutes. And this also gives us the opportunity for convergence with the IT industry, because the standards Milan builds on, or AVB, they're written by the IEEE. And this is a foundation we can share with the entire IT industry. Some few essentials. Another reason for Milan is that we're all in the live sound industry. Live sound is one of the most challenging jobs. It's the highest requirement for audio stability, and in the same we have this necessity for fast deployment. You may come into the stadium in the morning and the show is in the evening, and it's about 500,000 watts of audio and 500 devices to be networked. So how to make that happen? There is no time for fiddling around. It just has to work. So we come from that market, and we are more even forced to create something that does that job in an easy and reliable way. And above that, the network must be future-proof. Our product life cycles are around 15 to 20 years. So we have to look into the future and guarantee that the product we sell today still has a value in 15 years. A network product, it seems like impossible. So the only choice we have is to use standards where we know they will still exist in that time. Okay, and we also see that in future, audio, video and IT must coexist on one network. This is a given paradigm, so we need technology that can deal with this. And again, Milan, building on AVB, can ensure that there is no limit in the standard itself to this. So, and this is a very important conclusion, Milan is not made for competing with other network standards. That's not the target of the whole thing. It's more like we have to choose to do this in order to be able to create future-proof systems and a value that has a long-term horizon. And Milan isn't created by a single entity. It's not a small group of freaks or so. It's created by leading manufacturers together. So, Milan is not just enabling network connectivity, it is our grid to build on for the future. With this background, I want to hand over to Tim Booth from Meyer Sound, and we will go into technical benefits of Milan. Thanks.
Thank you, Henning. So actually I'm going to share this with Morten. Morten's going to get deeper into the technical. I'm going to talk a little bit about the journey. So, what are audio systems today? Things used to be pretty simple. I've been doing this for a while. I'm sure a number of you have been doing this for a while. It was pretty basic. You know, we used to do shows with 16 inputs. It was all analog, a few loudspeakers at the other end of it. Things were easy. Single XLR cables worked brilliantly. Very easy to use, great user interface. Unfortunately, it's very limited. And as Henning was talking about, you know, we're doing shows now, and also installation market is similar, where there's not a handful of devices or dozens of devices, there are hundreds of devices and thousands of channels of audio moving around. So this old way of working was very limited. And so we needed to look at how we could expand on this. And this is where networked audio really began, is to really leverage the power of the network for these much more complex systems. Unfortunately, we left simplicity behind. This XLR analogy works well. We like that simplicity as audio professionals. We're not IT professionals. And so, wouldn't it be nice if we could get back to that simplicity, yet have the flexibility and power of modern networking? So what is required for the future? I think another key thing to think about here is, again, we go back to those old days when we had 4 microphones, a small analog mixer, and some loudspeakers. The individual products were very significant. And sadly, even for us as manufacturers, the individual products are no longer significant. And the individual products don't have as much value. It's the entire system as a whole that has value. And the network has become the grid that ties them all together. And so the network becomes very, very critical. But without the latest technologies, the network starts to become the bottleneck in creating that system, making that system powerful, making that system easy to use. And so again, the past, individual products, very simple, straightforward. The network improved connectivity. The future is a future where the value and the function can be defined by the grid and how well the grid works, and that texture of networked integration. And so I'm going to turn it now over to Morten, and I'm going to return to this. Let me say one more thing about this last element here. Where do the users fit into this? Again, that's very important for us. As networks started to take off, we started, as audio people, started to get worried that IT professionals were going to start taking our jobs. It's not a big, serious concern, but we didn't want to be network IT people. The users are also, our users did not want to become IT professionals. They wanted to be audio professionals or video professionals. So the users are very key to fitting into this solution. So again, with that, now I turn it over to Morten.
Thanks, Tim. I could swear this is the AES and not the drum hall at the NAMM show, but anyways, can you guys hear us out there? Okay, good. So I'll talk a little bit about Milan and what Milan is and the technical side of it. Let me actually, so this thing here shows on one side various protocols, audio over network protocols that build on the legacy Ethernet switched Ethernet fabric as we know it. They're all good protocols in their own right, but they are suffering from the fact that they are leveraging an underlying Ethernet structure that does not really support quality of service and deterministic delivery of data, hence deterministic presentation time and such. So what Milan is a protocol that is built on top of an extension to Ethernet called, used to be called AVB, now it's called TSN, time sensitive networking. It's being used in robotics, production, anything where you need deterministic delivery of packets and information. It has been around for a while, and you guys have probably heard about it maybe 10 years ago and said, oh, AVB, it's going to solve everything, and then nothing happened because it was still just 3 letters, and a protocol itself does not guarantee interoperability. It's a necessary step towards interoperability, but it's no guarantee. So what Milan is, I actually use a little anecdote here from maybe another world within IT. Maybe when you, if you guys are old enough to remember when wireless networking started happening, maybe early 2000s, late 90s, and you would go to a hotel and you would try to connect your laptop, and maybe it would work, maybe it wouldn't, depending on the technology your laptop had and the technology the hotel had. And so the manufacturers saw that as a big problem. Right? Yes, we're all following the standard, but we're using slightly different corners of the standard, so we want to interoperate. So they created an organization called the Wi-Fi Alliance to come, and they had the Wi-Fi logo, and then they narrowed down the specs. It's the minimum everybody has to do, so everybody can communicate at some minimum level. They created a logo program. And after that, when we all started calling it Wi-Fi instead of 802.11, and we would buy products with the Wi-Fi logo on it, it will magically work. And today, we don't even think about whether we have an Apple or an Android or whatever when we walk into a restaurant or a bar. Of course it works. It's Wi-Fi. It works, right? So, and that is what Milan is for AVB. Milan is the Pro Audio Interoperability specification sitting on top of this newest extension to Ethernet. So the Ethernet protocol have evolved over the last 50 years. In the beginning it was over coax and collision based, and then it was twisted pair through hops, then switches came along, then rapid spanning tree, VLANs. All these things have been evolutions of Ethernet that have made it better and better suited to modern applications. And what AVB or TSN is just the latest evolution of Ethernet. What Milan is the protocol that sits on top of that makes pro audio devices talk to each other. So there's a few different components of that, and I'll not go deep into details, but I'll talk a little bit about formats. So AVB allows many different formats, many different sample rates, many channels packed in streams, and 32-bit and 24-bit and 16-bit and different compression schemes and stuff. So what Milan says, like a base stream is a format called AAF, which is the audio format that Milan is using. It can be 1 to 8 channels and 32-bit. So any listener or receiver must be able to receive a 1 to 8 channels stream in AAF format with 32-bit precision. Talker can, which is the source, can produce any stream from 1 to 8, whatever makes sense for the device. If it's a 2-channel wireless microphone receiver, it would send a 2-channel stream. It's so on and so forth. So that's the next bullet, yeah. And a little bit of the bandwidth. The AAF format packs really nicely. So on a gigabit Ethernet, you can have 360 channels and 48 streams, 8 streams each. And that's just on one link. The nice thing about AVB and Milan is that the data only traverses the links where it's needed. So if you have a source stream up here and you have a number of switches and devices, if the device down here doesn't need the stream from up here, then that link doesn't need to consume the bandwidth. So you can have much more than 360 channels on your network. And also, this is part of the TSN or the AVB, as you can never use more than 75% of your network for streaming. So there's always 25% left over for what we call legacy traffic control and monitoring. And even if you're doing firmware updates on some of your devices and trying to consume a lot, you'll never be able to steal bandwidth away from your streams, so your streams are guaranteed. So again, because we're using this modern underlying Ethernet functionality, we don't have to worry about control taking quality of service away from our audio. It's just built into the switch fabric. So we have, in some situations, it might not be feasible to use 8-channel streams. Let's say you have a mixing console and a stage box, and you want to send 16 channel or 32 channels. Maybe it's a little bit overkill in terms of overhead to send 4 8-channel streams. So there is an optional high capacity stream option, which is for more specialized parts of the network. But you always have to support the base format. In terms of media clocking, we AVB, just as most of the other media networks out there, it's based on a time protocol which is based on IEEE 1588 that allows all devices to have the same perception of time within sub-microsecond precision. But in AVB, we're actually not using, the media clocking is not directly derived from that, which means you can have many different media clocks. They don't necessarily have to have a fixed relation to global time. So you could, for example, in your network, have some stuff running 48 kilohertz, some stuff running 96 kilohertz, or even, and these rates do not have to be synchronous to each other. So that gives some flexibility with clock domains. In regards to live sound, for example, when you have a music festivals where you typically might have multiple consoles, it might not be feasible to synchronize everything up to everything, so you might want to have separate clock domains for each of the consoles, and maybe you have a device that have sample rate converters that can mix it together, where that's feasible. So there's nothing in Milan that precludes you having multiple asynchronous sample rates. Some of the other networks only support one asynchronous sample rate. So the other thing that we have decided to define as well is how to do redundancy. We felt that it was necessary to make sure that each manufacturer do not choose their own way to do redundancy, because again, we want to make sure that mixer console manufacturer A and speaker system manufacturer B can actually utilize redundancy and use the same scheme. So Milan also specifies how redundancy, dual LAN redundancy, is supposed to be done. So if you want the Milan stamp and you're doing redundancy, you have to do it the Milan way. And so in this case, here you have, these are very simplistic drawings, but you have two networks, the upper one and the lower one, and you have a break and a wire on one with the primary, and it will seamlessly switch over to the secondary. Yeah, it's not a lot of magic in that, but it's important that it's specified. So at last, I started out talking about how Milan was like what the Wi-Fi Alliance was for 802.11, and it's the reason why all our computers and PDAs can, do you even use that word anymore, PDA? No. Pocket computers It works everywhere. So, and I also mentioned that there's the logo, there's the Wi-Fi logo we all know, and nobody would want to buy a device that wouldn't have the Wi-Fi logo now. When it was initially brought on, it was very important to distinguish between the devices that had the logo or not. So back to an open standard alone does not guarantee interoperability. So it's important with independent certification. We want to make sure that devices are being certified to be Milan compatible, and they're only allowed to put the Milan logo on after they're certified, which will then guarantee interoperability and a good end user experience. So it also helps, of course, build end user confidence, because we know it will work and it will plug together. So is there more to say here? Yeah, so the switches are AVB switches. So we're not talking about Milan switches, because the underlying network infrastructure is AVB or TSN. So the switches will be AVB switches, but there is an avenue certification for those AVB switches to make sure that they are living up to the requirements of the IEEE specification. And then there's a Milan certification of all the endpoints in your system. So your speakers, your amplifiers, and your mixers, and so on and so forth. So this program currently, I think most of all of the manufacturers that are presented up here are currently already working through certification. A few are through certification. So the program is up and running, and we're improving, of course, the certification specs as we go along to make sure that whenever we find areas where a mistake is allowed to fall through the cracks, then we improve on the certification and so on. And I believe that ends my part, so I'm going to give it back to Tim now. Thank you.
Thank you, Morten. So, as I mentioned, we've been on a journey here, and I just wanted to continue on a little bit how this evolved. And again, how did Milan evolve? So, back in 2016, it's been a long day already. Meyer Sound, L-Acoustics, and DMB came together. And again, we realized we did not want to compete on this. Our customers didn't want us to compete. And we realized as a group that the underlying technology was exactly what we needed to solve our customers' problems. And so we wanted to take this technology and bring it to our customers, and again, we decided we're not going to compete. We're going to work on this together. And we also realized is that as manufacturers, we wanted to own this technology. Now that doesn't mean Meyer Sound owns the technology, or DNB, or L-Acoustics, or Adamson, or any of the other members own the technology. We all own the technology, and that benefits our users. So if one of us decides to go do something different, if L-Acoustics decides to go make furniture next year, then the technology keeps going. And the other part of it is, again, we are fierce competitors. You have the top loudspeaker manufacturers represented here. We are competitors. We compete on everything. Again, I'll pick on L-Acoustics again. They don't even know what color to paint their loudspeakers. I mean, we've decided on black. They've got this weird brownish color. But again, we compete. We're competing to get our users to use our stuff, but we're not going to compete on this. It's more important to work together. And we define those requirements together. And so this is one of our favorite pictures, because this is actually, I'm more of a marketing type guy. I'm not a deep tech guy. These are the deep tech guys. And you can see DMB, L-Acoustic, Meyer Sound, Luminex, a switch company, Adamson, I think Morten had left the room when this photo was taken. They work together. In fact, as we speak, they're in an office building about 15 minutes from here having a conversation about the next evolution of the standards. Some people are getting nervous. The decisions may be made without them being there. But again, we work together, and we work together under the Avenue Alliance. The Avenue Alliance is a non-profit organization that creates a framework for us to work together. and make these standards and in a proper way. And so again, we do it in face-to-face meetings. We also collaborate on the technical, but we also collaborate on the marketing. We also want to make sure our message is sent to the customer base properly, and so we collaborate there. Plugfest, this is another thing we do. We bring all of our gear together and we plug it together. We make sure it works. So you have a room with competing products all plugged into each other and they function. And this is how we guarantee interoperability and functionality for our users. And as Morten also talked about, we collaborate on the certification. So again, we are making Milan together. We're making sure we interoperate. We're collaborating on these open standards. And we're owning these future technologies. And we're allowing it to adapt for the needs of the future. And we've only really started. There's much more to come in AVB and certainly in Milan. And you're going to see that in the next few years as more parts of the standards evolve as we work together. And so with that, the Milan is the business requirement. I always miss the last point. We see this as a business requirement, not just for us as manufacturers, but also for the users and the installers. This becomes a business requirement, not just a technical requirement. Our little tagline is Milan is by the industry, for the industry. So I'm now going to hand it over to Genio, and he's going to talk you through what's really happening in the field. Because the exciting part is, up until this year, Milan was just an idea, and this year it became a reality. So, Genio?
Okay, so what I like to show is a bit, let's say, that we not talk about something that is theoretical, so it already happens in the field. So I have chosen a few examples. So and actually it was funny because I just learned about this project, about the Arcade Fire Tour that was started in 2017 at a coffee talk at our company, when actually the tour was already ongoing and running. So, and we just had released before already, let's say, some early versions that we worked out, started on the Milan working groups together, and so some engineers this time from Medus and Solotech had, without our knowledge, decided to bring this already on tours, and so we was actually expecting that they get in touch with us, or they should have, but at the end it never happened. So at the end then it has taken quite some time to retrieve a bit of information about this, and so we learned that it was not really a small network, so it has 92 network amplifiers. Everyone gets its own audio signal and control over AVB. And they used some Avenue certified network switches and some AVB processors from us. And yep, so they did it across over 50 locations without any incident. They had prepared some kind of analog fallback, but at the end it never was required. So, and I think also for the other companies, so this was already a good proof of concept to say, okay, we're going in the right direction. It means that our users for this do not need to have IT driving license or certification stuff to do. At the end, it does what they want to do. They plug it together and doing their show, and can concentrate on running the show. And then further, another installation that proves how well it works. That's the Hollywood Bowl in Los Angeles, and so they have the installation since April 2018, and during the summer season it's running 24/7. So they never switch off the system. There is no extra network controller on it. It's just plugged, and they are running the shows. Stuff is set in standby at the evening and waked up in the morning, and that's it. And So yeah, it runs quite well. So then this year, for example, there is the Marcoussis tour. That's something that has SSE Audio Group, now also part of the Solotech Group, done, and it just finished, and they have made 72 shows, 68 locations, also used Hyperreal sound multi-channel application and plugged in everything together based on the ABB Milan network. And again, running the shows without incidents every other day on another venue. They also had different setups, so the setup changed from day to day. Also there it was no issue, nothing running. Here, this one is, I would say, the largest one I'm aware of. That's the Rammstein Stadium Tour that was done this year, also by SSE Audio Group, and they really had 186 amplifiers running on this show, everything connected together, one control and audio network. It was a really impressive thing, and yeah. Also a little bit an overview about new installs 2019 that was done. So for the Europeans, one is the Orange Velodrome in Marseille, very big stadium, more than 300 loudspeakers, 51 amplifiers, running large football games. They are really taking care about that the system is running. For example, what they are doing is for every football game, they do not rely on mains power, they switch over to generators so that whatever happens on the mains grid, the show can run. And they have decided to use the technology and are happy with it. Also on cruise ships, the circuit. Another thing that's actually a little bit older, that's the Scott Trade Center. That's something where ABB also was chosen, and that's a relatively early project, and I would say that's an example of where we have seen some pitfalls between switch manufacturers and installation, and the good behavior was, or the good experience was, okay, there was some difficulties on setting it up to make the right switch configurations, etc., because some IT switch manufacturers decided that they want to give all control to the IT department, so it's unfortunately not that you have one button to switch ABB on like it is on other switch manufacturers. Here you had to configure everything single, and so there was some issues, and at the end also it proved within the Avenue Alliance, let's say, the issue or the problem for the setup arrived, so it came to the community. Nobody pointed to each other and say, hey, it's your fault, we don't care. So everyone was interested to get it running, and at the end it's a very good example on how it can work when manufacturer works together and not, let's say, try to cheat out the other one, because at the end our clients, from our perspective, they do not want to learn about networks. It's something they want to have to transport audio from A to B and control from A to B, and that's it. And the best thing is when you do not need to talk about it. And here also with an example about a few shows that was new in 2019. So for example also the Bon Iver tour that's currently ongoing, and so based on that, we really can say it's not a theoretical thing. So it was a long journey when we take it from the beginning of the ABB standard to what we do now, but it's really promising when it's used in the field, how it's working. And yeah, with this, I like to close the session. Yep.
So, thanks, Genio. Very impressive. So that was kind of the end of our presentation. Maybe there's one thing to add here as a conclusion. As you might have learned from the slides, what will happen in relatively short-term future is that on productions or installations where there is a D&B loudspeaker system, an L-Acoustic loudspeaker system, or a Meyer or Adamson loudspeaker system, in these systems there will be an AVB network. And we invite other manufacturers to think about the benefit of maybe them sharing the same platform together with us. From the customer perspective, this is very close to an ideal scenario, what we believe we're creating here. Just as a thought, you know. So we're happy to receive questions if there would be any. I think there's a microphone. Yes, so the gentleman over there has questions.
Did you say that this would be used for mixing consoles and?
We have two mixing console manufacturers in our group, which is Avid and PreSonus. They have actually been using AVB for quite a while due to its simplicity for their users and due to them being independent from other standards and being able to plan long term. But when we founded Milan, they they dropped in more or less immediately because they could see the benefit of, well, let's join together, doing the same thing and not something incompatible.
Are you trying to get other ones as well?
Yes, and we are. More questions? We still have some time. Yeah, we have. Feel free. Oh, the gentleman here.
So, other than user-friendly, compared to Dante, what you're bringing to the table? Because Dante, we could do 96K, we can do pretty user-friendly paths.
Is this on? Okay. Actually, Morten's got a good answer. He gave it this morning.
Yeah, so apart from all the other things, the fact that it's open and we can control it and we can control the cost, and et cetera, what really makes the difference is that the underlying QoS that we're basing this on actually guarantees, not just almost and most of the time, it guarantees that the data will get to the end at a certain time with very high precision. Most of us are making line arrays, and you can imagine some of those line arrays, each speaker in the line array will be an active node on the network, and if we can't control the arrival of the sound with subsample precision, then we can't control our throw. And that's simply not possible with the other networks unless we prevent any form of control traffic to be there. And regardless of what you might have experienced in smaller setups, etc., I can show how I can make the audio move several samples on the left side and not on the right side if I push enough data through the switch. At Adamson, for example, today, we're using the control and monitoring bandwidth to send lots of FFT information about like the recalculating, say the spectral impedance of all the speakers. We don't have to worry about that. We can do that, where you see in a lot of other systems, say, oh, use this Ethernet for audio, and use this one for control, or use this for audio and control, but don't put any video on. We don't care, it's AVB. If video comes in and reserves some bandwidth and it's there, it can get it. It cannot affect the audio. And I think it's also very interesting that 4 live sound line array manufacturers all independently chose the same standard. You could say Meyer was an early adopter, so they almost had to do it because they had already bet on it. Yeah. But the other 3 of us, independently, before we even knew each other were working on it, we all came to the conclusion that the only thing that can work with the reliability that we need in this industry, because, you know, there are certain shows, if our system breaks down, like let's say you're doing the Super Bowl, we're out of business. Like, the reliability is so important, and predictability and deterministic networking. And so yes, so that's really another thing on the technical side that it brings
Yeah,
to the equation.
I'll add one more thing on the timing. You know, all four of us as manufacturers, we're continuing to develop products. Right, we're not done. We keep going. Future technologies that we're working on require extremely precise timing. And you've seen that with some current products, and the future is wide open to what we can do, but we require precise timing. And another thing that was also alluded was the fact that it's an open standard. We've known through the history of our industry, open standards withstand the test of time. You know, we have to build products for our customers that they can be using 20 years from now. And that's guaranteed with an open standard.
On that note, 10 gigabit switches and fiber optics and all that is coming along. How's that going to play with your bandwidth? Is that going to be expandable down the road, or
Yes,
because
I mean,
a lot of the fiber stuff?
The standard also is not defined absolutely now. We have a standard from which everything is based on. The standard can also evolve. As networking hardware evolves, we can evolve the standard. You know, we can think of, we know bandwidth is going to increase, that's a guarantee. We can continue to evolve the standard around whatever that turns out to be. The core AVB standard is still solid.
The fascinating thing is that we actually, as audio manufacturers, we have become active in the IEEE. The IEEE traditionally was an IT industry standardization organization, but now things are converging, and we say, okay, let's become active here. Let's create the standards. Let's not be passive waiting for something to come which we would use. No, let's make it ourselves. And suddenly we can become creative and think of products which you cannot see on the show floor here today, with completely new possibilities. And this is the opportunity we want.
I'll make one other addition to the brilliance of an open standard. We know that to make these systems work well, someone's going to have to create software, right? The user experience is frequently defined by software. With an open standard, some kid at the local university could actually develop a controller that none of us thought of, that turns out to be brilliant. And for the users, it might end up being the best controller ever created. And because it's an open standard, we allow the entire industry to create great products, not just the four of us.
Okay, I think our time is over. We have to leave time to the next presenters.